Section number 5 is entitled Powers of Whole Numbers. Probably should be called powers of rational numbers. Now, years ago, we saw a need for a shorthand notation for repeated addition. Like 2 plus 2 plus 2 6 times, we wrote that as 2 times 6. 8 plus 8 plus 8, a lot of times. 5, 6, 7, 8, 9, 10, 11 times. 3, 6, 9, 11 times. The shorthand way of doing that is just 8 times 11. What if you wanted to add 13, or to note that you wanted to add 13 to itself 100 times? You wouldn't really want to write down 13 plus 13 100 times. I mean, you can do what I said and denote that it's 100 times, or you can just say it's 13 times 100. There is definitely a need for this shorthand notation. Shorthand notation happens to be called multiplication. So when somebody asks you what's 7 times 5, well, that's 7 plus 7 5 times, or if you prefer, 5 plus 5 7 times. But now, what if we have 3 times 3 a number of times? Say 6 times. It'd be nice if we had a shorthand notation for this. Since the number that's being repeatedly multiplied is 3, I write 3 down. And in the upper right-hand corner, I put how many times I'm multiplying it. That's the shorthand notation. 2 times 2, 7 times. 3, 4, 5, 6, 7. You don't have to write it that way anymore. You can just write 2 to the 7. This is not 14. We have a very nice way to write 2 times 7. And it is not 2 to the 7. It's 2 times 7. Okay, this here is not 3 times 6. We have a nice way of writing 3 times 6. Okay, if you don't know what 3 to the 6 is, fine. I mean, it's not fine, but okay, you don't know what it is. You can't know everything. But it's not 3 times 6. Why would we, writing 3 times 6 is as much work as writing 3 to the 6. Okay, so it is not 3 times 6. So there's definitely a need for this new notation. It's definitely a need. Now, if this is read as 5, this number, to the, that's 4, to the 4th power. To the 32nd, this is read as 11 to the 32nd power. Okay. 5 to the 2nd is read as 5. Well, I should have the word raised. 5 raised to the 2nd power. 5 raised to the power is 2 to the base, and then say squared. If it's 11 to the second power, it's 11 squared. If negative 18 to the second power, it'll be negative 18 squared. 2 to the 6th, the 2. Whether it's 2 or 12, doesn't matter. This is called the base. This number is the base. The number up there is the power, or you can call it the exponent. So if you have a to the b, and a to the b, a is the base, and b is the power or exponent. That's the base, that's the exponent. What does this mean? A times A times A. How many times? Whatever B is. If B is 7, multiply A by itself 7 times. So let's evaluate some of this stuff. Evaluate the following. Evaluate 3 to the 4th. Well, this means 3 times 3, 4 times. Now, most of us know up to the 12 times table. Let's assume that's true. Well, 3 times 3, we should know, that's 9. 9 times 3, and 9 times 3, nothing went past 12. 9 is less than 12, 3 is less than 12. So we should know what 9 times 3 is, 27. So when I multiply 27 by 3, we probably won't know that one, because this number is more than 12. Now how I would do this is I would say 3 times 3 is 9, 3 times 3 is 9, oh, 9 times 9, both of those numbers are less than 12, is 81. Okay, 9 times 9, 81. If somebody asks me what 2 to the 6 is, I can, well, let's write down what it means. It means to multiply 2 by itself 6 times. You can go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. But once you got up to 8, 2 times 2 times 2 is 8. 8 times 2, excuse me, you should know is 16. But 16 times 2 you may not know. You only know up to the 8 times table. What you should realize that both of those in the boxes are 8. 8 times 8, 64. Okay, now if, for example, somebody asked me what 2 to the 7th meant, equals 2, 3, 4, 5, 6, 7. I would say, you know what, that's 8 times another 8, that's 64 times 2. If you need to, go on the side and compute 64 times 2, 28. Okay, otherwise, you'd have a number of multiple table on the side. 2 times 2 you should know is 4. 4 times 2 you should know is 8. 8 times 2 is 16, you should know that. 16 times 2, you may not know. It's 32. 32 times 2, you may not know that one. You'd have to do it on the side. Well, it's 64. And 64 times 2, you may not know that. So you'd have to do it on the side. That was 3 multiplications on the side. I only had to do 1. You should definitely panic and use some common sense how to evaluate these things. And don't run for your calculator. You know what 8 times 8 is. when you see 2 to the 6 and you write down that it means this, don't go, oh my, that's a lot. That's 8. That's 8. 8 times 8, 64. If you didn't see that, at least see this. This is 4 times 4 times another 4. 4 times 4 is 16. 16 times 4, maybe you need pencil and paper to do that. But that's only 1. 2 times 2 is 4, times 2 is 8. 8 times 2 you should know is 16. You may not know what 16 times 2 is. It's 32. And then you may not know what 32 times 2 is. Okay, so try to group them. Try to group them. If you wanted to know what 10 cubed is, we're still under evaluate. If you wanted to know what 10 cubed is, well, think about what it means. 10 times 10 is 100. 100 times 10 is 1,000. If you have 10 $100 bills, here's $100 bills, and you have 10 of them. It's $1,000. If you wanted to know what 1 to the 5th is, it's not 5. It's 1 times itself, fine, 5 times. But it doesn't matter how many times I multiply 1, I get 1. 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. You want to know what 1 to the 7 is? Well, it does mean this, 3, 4, 5, 6, 7 times. 1 times itself 7 times. 1 times 1 is 1. That answer times 1 is 1. That answer 1 times 1 is 1. That answer times 1 times 1 times 1 is 1. You needed to do 2 to the 5th. 5 times I multiply 2. You can go 4 times 4 is 16. Now you may not know what 16 times 2 is, because that's beyond the 12 times 12 table. Don't run for your calculator. You should say, well, that's 8, and that's 4. 2 times 2 is 4, times 2 is 8, and 2 times 2 is 4. And you say, oh, that I know. Both of those numbers are less than 12, or equal to 12. 8 times 4, 32. And there's the answer. Okay? You know a lot of these, even though you may think you don't. Just arrange it more friendly. 8 times 4. I know that. 4 times 4 is 8. I know, see, well. So what happened here? Oh, 4 times 4 is not 8. 4 times 4 is 16. But 16 times 2, I don't know. I only know up to the 12 times table. Well, put this 2 in with the other group, and hopefully it won't go beyond 12. And it didn't. This is 4. That's 8. 4, 8, 32. But bottom, however you get it, multiply 2 by itself 7 times. Now, what if you had 2 to the 7th divided by 2 to the 5th? Now, neither of those numbers are 2. None of those numbers are 2. 2 times 2 7 times is not 2, and 2 times 2 5 times is not 2. So you cannot cross off the 2's and say, oh, that's 1. I mean, I'm not going to argue with you. 2 over 2 is 1. 2 over 2 is 1. That's a 2, and that's a 2. And when you divide them, get 1 every time. The number I just wrote is not 2, And the number that I'm writing right now is not 2. So don't say, oh, 2 over 2 is 1. Absolutely. 2 over 2 is 1. But over here, we don't have 2 over 2. In fact, the top is 2 times 2, 7 times. 4, 5, 6, 7 times. The bottom is 2 times 2, 5 times. All I did was use the definitions. And now I agree with you. 2 over 2 is 1. 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 Multiplying by 1 doesn't get you anywhere. You don't even need to put the 1s down. They don't get you anywhere. 1 times 1 times 1, 5 times is 1, times 2 times 2 at the end is just 2 times 2. That is, it's 2 squared, which happens to be 4. I'm more concerned about the 2 squared. How could we have known that sooner without doing all of this? Well, if you picture 7 2's on the top, and it's pretty easy to picture it because and if you picture 5 on the bottom, there they are, and you say, you know what, 7 is 5, it's 2 more. The first 5 will cancel out, and you'll have 2 more. That is, to do 2 over 2 to the 5th, it'll be minus 5. 2 squared. There are 2 more on the top than on the bottom. All but 2 2's cancel out. All of these canceled out except the 2 2 in the top, which is 4. There's absolutely no need to calculate 2 to the 5th and then divide. Because oh, you can do that. You certainly do that. You need to do it. It wouldn't be wrong. But when the numbers get really big, you don't want to do problems like that. If you have 3 to the 6 divided by 3 to the 3, I claim this is going to be 3 to the 6 minus 3, which 3 cubed, which means 3 times 3, 9 times 3, 27. The reason that's the correct answer is you have 3 6 on top being multiplied. 3 fast is the 6, and you have 3 fast is the 3 on the bottom. Things that are being multiplied, we're multiplying the 3. It makes the 3 factors. In the bottom, we have 3 of them. Well, 3 of them are going to cancel out. And you're going to have 3 left. Why do you have 3 left? Because 6 happens to be 3 more than. So you did get 3 to the 6 minus 3, which is 3 cubed, which has 27. That is, you don't have to do this anymore. Somebody asks you what 3 to the 6 over 3 cubed is. It's 3 raised to the, excuse me, 6 take away 3 is 3. So that's 27. 3 times 9 times another 3, 27. The same 2 non-zero numbers. 0 over 0 is not 1. You divide the same 2 numbers, and they're not 0. You get 1, provided the numbers are not 0. If the top and the bottom are the same and you divide them, you get 1. Only if they're not 0. 0 over 0 is not 1. Okay? 0 over 0 is not 1. Well, 3 to the 5th, that's not 1. It's some number. You want to compute, don't compute it. It doesn't matter what it is. because the bottom is the same. On one hand, this is 1. I'm dividing the same two numbers. Dividing the same two numbers. You want to calculate 3 to the 5th? Fine. Whatever you get, you're going to divide it by that same number, and you're going to say, oh yeah, that's 1. Using our little formula, we do 5 minus 5, and that's the power. 3 to the 0. 3 to the 0 is 1. If I had 13 to the 5th over 13 to the 5th, that would be 13 to the 5 minus 5, which is 13 to the 0. And since the top and the bottom are the same, it also equals 1. It is 13 to the 0 equals 1. If instead it was 18 to the 5 over 18 to the 5, well, that's 1. And it's also 18 to the 5 minus 5, which is 18 to the 0, which is 1. Now, if you had 0 to the 7 over 0 to the 7, well, 0 to the 7 is 0, and 0 to the 7 is 0, and 0 over 0 is not 0. It is 0 to the 7 minus 7, which is 0 to the 0. But trust me, we don't know what that is. Plug it in your calculator, and you'll see it gives you an error. As long as x is not 0, this is 1. Provided x is not 0. If x is any number but 0, raise it to the 0 power, you get 1. This is a theorem. It's a fact that you should know like you know your name. In fact, let's leave it up there. Any number to the 0 power is 1, provided that any number is not 0. The number I just wrote is not 0. Raise it to the 0 power 1. This number is not 0. Raise it to the 0 power, get 1. 2 plus 3 is not 0. It's 5. Raise it to the 0 power, you get 1. That is, you get 5 to the 0 power. As long as the base is not 0, if you raise it to the 0 power, you get the number 1. 7 minus 2, or 17 minus 2, is not 0. Raise it to the 0 power, you get 1. I know this isn't 0, because 17 minus only one number, namely 17, is 0. So 17 minus 2 is not 0. Last one, if I ask you, what is 5 minus 5 to the 0 power? You should say, well, 5 minus 5 is 0. Oh, 0 to the 0 power, I don't know what that is. It's called indeterminate. Okay, it's indeterminate. We can't determine it. We cannot determine it. Okay, that finishes the section on how is a whole numbers.